Today's problem, sum of subarrays, difficulty is medium. Given an array, find the sum of all the subarrays of the given array. Guaranteed that the total sum will fit in a 32-bit integer. Okay, examples. Array 1, 2, 3. So what are all the subarrays? Well, you've got 1, 2, 3, 1, 2, 2, 3, 1, 2, 3. Sum them all up, and you get 20. And this one, these examples, unfortunately, are a little bit too simple to be useful. Array size is going to be somewhere between 1 and 10 to the 5th, 100,000. Array elements will be between 0 and 10 to the 4th, 10,000. Time complexity is expected to be linear. Auxiliary space, O of 1. Let me think about that for a second. Yeah, that's probably right. Topic tags. Okay, nothing interesting there. I think the way to go about this is to, let me get a more slightly more useful array. We'll say 1, 2, 3, 4, and 5. Okay. I think a good way to go about this is to figure out how many times or how many subarrays will each element appear in. So let's say we picked, I didn't mean to do that. Let's say we picked, okay, good. Let's say we picked this one here. This is at index 2. We're going to pick the 3, which is at index 2. Now, how many subarrays is that going to appear in? Well, it's only going to appear in subarrays starting at index 0 or index 1. So let's see. Let's start with index 0. So in that case, it would appear in 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 4, 5. All right, so that's 3 subarrays. Now, what about in subarrays starting at index 1? It's gonna appear in 2, 3, 2, 3, 4, and 2, 3, 4, 5. Again, that's 3 subarrays. What about subarrays starting at index 2? It's gonna appear in 3, 3, 4, and 3, 4, 5. So each time it's 3. It's gonna appear 3 in 3 subarrays starting at 3 different indices. All right, see if we can find a pattern here. Let's try this one. Let's try the 2. Now that is at index 1. Now the 2, of course, is only going to appear in subarrays starting at index 0 or 1. So let's say indexes starting at 0. It's going to appear in 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. That's 4. What about subarrays starting at index 1? All right. Well, it's going to appear in 2, 2, 3, 2, 3, 4, 2, 3, 4, 5. So 4 occurrences in 2 different subarrays. So the pattern here looks like, let's see, 2, so that one appears in 3. All right, this one appears in 2. At index I appears index 1 appears in subarrays starting at two different indices. So what we have there actually is I plus I. Let's do it like this. I plus 1. And the number of subarrays that it's going to appear in, well, let's see. The element at index 2 appears in three subarrays. Doesn't matter what index you start at. You can start at 0 or 1 or 2, but in all three cases it appears in 3 subarrays. Now this one here, if you start at index 1, that one appears, you can start at index 0 or 1, but in either case it's going to appear in 4 subarrays. So that number is going to be I plus 1. Actually got more room over here. I plus 1, and that is going to be n minus I. Okay, so now we multiply those, and that will give us, for each element, the number of subarrays that it appears in. And then we would have to multiply that times the value of the element, add them all up, and that should give us the total sum. Now, I mean, let's try this out on one of the simpler arrays here. Oh, wait a minute. No, I don't want to do that. I don't want to erase all that. Let me see if I can erase some of this. All right. Let's do this one. The 1, 2, 1, 2, 3. 1, 2, 3. All right. So we'll start with 1. And what we'll have is 1 times n minus 1. N in this case is 3. So 1 times, oh, not n minus 1, n minus the index, which is 0. So 1 times 3 times index plus 1. The index is 0 times 1. All right, that equals 3. Okay, good. We go to the 2. Now n minus the index, 3 minus the index, which is 1, is, well, actually, let's start with the value. Value, and then times index, or n minus the index, 3 minus 1 is 2. And index 1 plus 1 is also 2. So that gives us a total of 8. Let's go to the 3. 3, we'll have 3 times n minus the index, which is 3 minus 2. And then index plus 1, 2 plus 1 is 3, and that is 9. So now what we have is the contribution of each element to the total sum. So the 1 is going to contribute a total of 3. The 2 is going to contribute a total of 8, and the 3 is going to contribute a total of 9. So that is 9 plus 8, 17 plus 3 for a total of 20. And that is the answer that we're looking for. Okay, let's try an implementation of this. All right, here it is. N is the length of the array. We'll start out initializing a variable to 0, and then we go through the loop. And we'll do just what we did in the example, which is to take the value at each index, multiply it times n minus I times I plus 1. And add them all up, return the results. Let's submit it. Let's scoot this over so we can see the results. Okay. That's it. Let's see. Final thoughts. Yeah, not really. It's just the approach is just to not really to find to find all the subarrays, but just to find the formula that indicates how many times each element is, or how many subarrays each element is going to appear in, and then based on that we can calculate its contribution. It's the total contribution of each element to the total sum, and that's it. Go ahead and give the video a like. You can subscribe to the channel. You'll get a problem of the day in your inbox every weekday. And we'll see you next time.